Hello guys, welcome back to my channel. Today we will learn heap and heap sort. So in this lecture we will do how to build a min heap, how to build a max heap, and as well as we'll do the heap sort. So let's start with heap definition. By definition, a heap is a specialized tree-based data structure that satisfies the heap property. So, to understand the definition as well as heap, we need to understand its heap property. There are basically two heap property. One is min heap property and another is max heap property. So, the heap is a tree-based data structure that satisfies either min heap property or the max heap property. So in min heap property, the value of its node is greater than or equal to the value of its parents. So if we draw a tree like that, here is 5 and here is 7. So in min heap property, what it should be, the value of its node, for example 7, is greater than or equal to the value of its parents. So 7 is greater than its parents 5, and with the minimum value element at the root and the minimum value element in the root. So this simple tree structure is in the min heap property, whereas the max heap is the opposite idea. The value of its node is less than or equal to the value of its parents. So if we just reverse this structure, so the value of 5 is less than or equal to its parent 7 with the maximum value element at the root, and the maximum value element is in the root. So this simple tree structure is max heap. So let's look this example in tree 1, where the value of its node is greater than or equal to its parents. So 9 is greater than or equal to its parents, 14 is greater than its parent 6, 16 is greater than its parents 11, 6 is greater than its parent 5, 11 is greater than its parent 5, and the minimum value element is in the root among all the values. So it satisfies the min heap property, then we call it a min heap. In the right hand side, this tree where each value like the node 5 contains the value is less than its parent 40, 10 is less than its parent 14, 6 is less than its parent 9, and the node value 14 is less than its parent 16, and 9 is less than its parent 16, and the maximum value is in the root. So it satisfies the property of max heap. That's why we can call this heap is a max heap. I hope all of you understand the min heap property as well as the max heap property. Now we will do how we actually build the min heap and max heap. So building heap property. Number 1, it is a complete binary tree. So if we draw the heap, it should be a complete binary tree. So in the previous example, here all the labels are full except the last label, where the nodes are inserted from left to right. So according to complete binary tree definition, that all the labels must be full except the last label, and in the last label we should insert the nodes from left to right. So these two heap maintain the same property. So building a heap, we should maintain this property. The structure should be a complete binary tree, and the next, before filling up the previous label, it can't go to the next label. So if we want to insert here a node, we can insert in this position. However, in this tree now this level is full. Now if we want to add another node in this tree, so we must start from here. So before filling up the previous level, we can't go to the next level. In number 3, any level fill up from left to right. So we should fill up this level from left to right, and the last property is inter-tree and subtree will follow any of the two properties, max heap or min heap. So we should maintain the max heap property or min heap property in any position in the entire tree. Do an example of building max heap and min heap. So to do this, we need to follow some instruction. So here is a set of data, and using this data, I mean the node value, we need to construct the max heap and min heap. So how can we build the max heap and min heap? So in the first step, a tree consisting of a single node is automatically a heap. So in the first node we have is 7. So the 7 is automatically heap because we cannot compare with any other values. There is only one node which is 7, and we can call it a single node tree. In step 2, we construct a heap by adding nodes one at a time. So we should add node one at a time. Step number 3, add the node just to the left of the rightmost node in the deepest level. So we need to add the node in the deepest level. So basically we need to add the node from left to right. So now we have only one node which is 7. Then our node is 9. So we should insert 9 here, the left, as a left child of this road. Now if the deepest level is full, start a new level. So here if we do this, there is no problem, we can also insert a node here. However, if you want to do insert another node, so we must insert here because this level is full. When this level is full, we should start from a new level. So that is mentioned in the steps, and each time we add a node, we may destroy the heap property of its parent node. So let's look here. So when we add 9 with 7 as its left children, so we destroy the heap property. We are constructing max heap. So in the max heap, every node has the value less than or equal to its parent. However, here is 9 is greater than its parent 7. So in that case, to fix this, we shift up. We need to shift up. That means we need to shift this value in up. But each time we shift up, we may destroy the heap property. So let's do it. We should shift up here. So in our case, it should be like 9 to 7. So here is step 1, and we should shift up the process and we get this one. And in step 2, we should again insert 4. So we should insert 4 in the right child of 9, and it does not destroy the heap property, so we are fine. In step 3, so we need to add the node which is 11. So we must add the node here. So when we add node here, it destroys the heap property because the parents of 11 is less than its own value. So we need to shift up here. So to shift up here, what we can do, we should do 9, here is 11, and here is 7. That means we shift up 11 to up position, and then in the right side is 4. So we may destroy the heap property of its parents, but each time we shift up, we may destroy the heap property of its parents. So we shift up here, but we destroy the heap property of its parent. That means here the node value 11 is less than its parent. However, in the max heap condition, the node value will be less than or equal to its parent. So in that case, we repeat the shifting up process and moving up in the tree until either we reach the nodes whose value do not need to be swapped or we reach the root. There are two conditions. So for example, if we have the value 8 here instead of 11, so we should write 8 here. Then we destroy the heap property with node 7, so we just shift up and write 8 here. And a single shift up does not destroy the heap property because we reach the node whose value do not need to be swapped. So the value 8 do not need to be swapped with the root. However, if we use 11 instead of 8, so in shift up process here we should write 11, and this process may destroy the heap property of its parent. So we need to shift up until we reach the root. So we need to shift up again. So when we shift up, the 11 should be here, then 9, and here will be 7, and in the right side here will be 4. And finally the node 13. So we should add 13 here. When we add 13 here, it destroys the heap property of 9. So we need to shift up, and for this we can write 13 here and 9 here. Still we destroy the heap property of its parents with 11. So we need to shift up again. So we need to write 11 here and we need to write 13 here. Now we built the max heap where the maximum element is in the root and in all other nodes value is the lesser than or equal to its parent. So the 11 is less than its parent 13, 7 is less than its parent 11, 9 is less than its parent 11, and 4 is less than its parent 13. So this is the max heap. Now we will do the min heap with the same node value. So in the min heap property, the node value will be greater than or equal to its parents. So for 7, then we add the node 9 here in the left side, and it maintains the heap property because the node value is greater than or equal to its parent. Then we add 4. However, when we insert 4 here, it destroys the heap property, so we need to shift up with it. So we should write here 4, and here is 9, and here is 7, and then we need to add the node 11. So we may add the node 11 here. Then we need to add the node 13. So we need to add the node 13 here. That means when a level is full, we must start a new level from left to right. So the tree maintains the heap property, so it's a min heap. I think all of you understand how to build the max heap as well as the min heap. Let's move on the heap sort. So how this heap concept we can use for our sorting. So in heap sort, the goal is sort an array using the heap representation, and the idea behind this, build a max heap from the array. So suppose we are given an array data and we need to sort this data using the heap sort. So in the first step, what we need to do, build a max heap from the array. So we need to build a max heap here. So here is 7 and 9 for max heap. The 9 should be in here, so we need to shift up and then add 4. We are fine with the max heap. Then we need to write insert 11. When we add 11, we destroy the heap property, so we must shift up. so here should be the 7. Again we destroy the heap property, so here should be the 9 and here is 11. Now we need to add the node 13, so we need to add node 13 here. However, we destroy the heap property, so we need to swap. Here is 9, here is 13. From here we need to swap again, so here is 13 and here is 11. So we build the max heap. Now swap the root with the last element in the array. Now we need to swap the root with the last element in the array. So the last element is 9, so we need to swap it. So here should be the 9 and here should be the 13, and discard this last node by decreasing the heap size. So if we represent this heap in an array, 9, 11, 4, 7, 13. So here the heap size is 5, so in that case we just decrease the heap size. So here is n equal to 4. Now call the max heapify on the new row. So again we need to do the heapify system after discarding 30. So we need to max heapify. So if we want to max heapify here, so what we can do, the 11 should be here and here is 9, here is 7 and here is 4. Then again swap the root with the last element in the array. So here the last element is 7, so we need to swap it with 11. So here is 11 and here should be 7. So the array looks like 7, 9, 4, 11 and 13, and we again decrease the size, so array equal to 3 and discards this node 11. Now again we need to max heapify this tree structure where 9 is here and 7 should be here after shifting and 4 is here, and the array look likes, and we need to again swap the root element with the last element which is 4. So if we swap it, the 4 should be here and 9 should be here, and we arrange this in the array like that, 4, 7, 9 and the other two items 11 and 13, and decrease the array size n equal to 2 and discard this node. So we have only 4 and 7, so we need to max heapify. So the 7 will be in the root and 4 in the leaf, and then again we need to swap the item. So 4 will be in the top and 7 will be in the bottom, I mean the children, and then again represents this into the array. So what we will get, 4, 7, 9, 11 and 13, and again reduce the heap size which will be n equal to 1. So when we will finish, repeat this process until only one node remain. Now we have only one node which is 4, that means we done the process. And if we print this array through a for loop, we can get the data 4, 7, 9, 11 and 13, which is in the sorted order. So I think all of you understand the heap sort. Now pause the video and try yourself. Make a max heap and min heap with the following nodes. And thank you very much for watching this video. If you still have any question, please leave your question in the comment box. I will try my best to answer all of your queries. Please like, comment and subscribe my channel.